Okay, so in this video, we're going to look at how to communicate with a three-layer architecture, three-tier architecture. So in the previous two examples, it was a two-tier architecture where the connections were from a computer to a switch and from a switch to a router. That's it. And even in the second example, it is from a computer to a switch to router. So the three-tier, so that's two layers or two tiers. Now in the third example, we're going to have a switch-to-switch connection on the top of what we already have. So that will be forming adding the third layer. So three-tier architecture. So as it is shown here, we are going to have just two VLANs, but the VLANs here are spread across the two switches. Okay, so VLAN 1 is connected to both the switches, as well as VLAN 2 is connected to both the switches. So traffic within the VLAN, say from a device connected to this switch, should be able to just go through this switch and reach the device in the same VLAN connected to the other switch. It shouldn't go through the router. Okay. Only if you have to communicate across two VLANs, then you have to go through the router. So that's what we're going to see now, how to set it up. So again, we could list down the IP addresses of the devices that we want to have. So let's see, this is 10.11, 10 dots is straightforward. The subnet mask is 24, so it should be straightforward. 10.1 will be the gateway IP address for VLAN 1, and 20.1 will be the gateway IP address for VLAN 2. And the host IP addresses range from 10, 11, 12, and 13 for both the VLANs. So let's go through the process. So let's see, have the network device switch, 2960 switch, set it up. One more switch, set it up here. Now let's say we have the end device here, the PC. One more end device here. So these two are part of VLAN 1. That's VLAN 1, 192.168.10.0/24. So the gateway is going to be 192.168.10.1. Again, if you go from the fundamentals, it's the same process, but let me walk you through that here. So for VLAN 1, it's 192.168.10.0/24. So 24, so it means the first 24 bits from the network and subnet, and the last 8 bits from the host part. So it's 10.0/24. So it's 192.168.10 dot 8 zeros. So all these 8 zeros form the host part. So the first available IP address would be the gateway IP address, that would be this. So that's why it's 10.1/24 is the gateway IP address. Okay. All right. So with that, we can now connect these two switches. So divide computers to the router switch here. So again, we follow the ordering. This is PC0, PC1 connected to interface 1 and interface 2 of the switch. So that's again in VLAN 1, which is already there. So let's now add a second VLAN. Make it 20. Okay. So that would be like the devices off here. Let's connect PC2 to this. And PC3 to this. Okay. Now let's set up the IP addresses right away. We didn't set it up yet. So desktop IP configuration. This is 192.168.10.10. 24 bits, so just leave it as it is. 192.168.10.1, that's the gateway IP address. For this one, it is 12.11 and then 10.1. For this one is 20.10 and 20.1 is the gateway IP address. And this would be desktop IP configuration 20.11 and 20.1 is the gateway IP address. That's VLAN 2. So let's do the same thing here. Okay, let's put the end devices. So PC4 is going to be 192, already have 10 and 11, so let's make it 12. 192.168.10.1, that's the gateway IP address. This will be 13. Okay, so let's connect them. Uh, let's now do VLAN 2 here. This will be 20. Already had 10 and 11, so let's make it 20.12. Okay. Okay, these are the two VLANs. Let's create the VLAN database. Click on the switch, go to config VLAN database. Already one is there. So this is just for VLAN 2. And same thing can do at this zero switch. Config VLAN database to VLAN 2. And now let's go to the interfaces. So 1 and 2 are in, 1 and 2 are in VLAN 1. Which is already set it up like that. Then 3 and 4 are in VLAN 2. So if you place the cursor on these two, it's 3 and 4. So let me zoom it. There's the cursor here, there is 3 and this is 4. So that will be interface 3 will be in VLAN 2. Interface, click outside somewhere, interface 4 is also in VLAN 2. These are access modes, so it can be only one VLAN. Now let's do the same thing here. So this interface 1 and 2, we want to be in VLAN 1, and that's what by default it is. See, 1 is in VLAN 1, 2 is also in VLAN 1. Now, interface 3 and 4 are part of VLAN 2. So go back to switch. Interface 3 will be in VLAN 2, and interface 4 will also be in VLAN 2. Okay, now we need to also be connecting the two switches so that traffic from one VLAN can go to the other VLAN. Even like within the same VLAN, we have to use the switch, right? So, and the switch has to, and this connection has to be a trunk connection because, so again, click on that auto cable and disconnect them. You should be able to figure out what cable you want. So you can see between two switches, it's kind of like, this is called straight through. Let me click. Display the name. This one is crossover. So this is a crossover cable between two switches. Anyway, so this is interface phi. If you place the cursor on the top of it, it's on both sides. So let's make switch phi, interface phi, either way to be a trunk connection because it needs to carry traffic belonging to both the VLANs. VLAN 1 may send to VLAN 1 or VLAN 2 may send to VLAN 2. So that's what I mean. Again, only across, we can avoid going through a router if you're communicating within the same VLAN. So if you're communicating from VLAN 1 to VLAN 1, you have to go through the switch across these two sides, or from VLAN 2 on this side to VLAN 2 on this side, you have to go through this connection. Now, from VLAN 1 to VLAN 2 on from either side, we have to go through a router. So we need a router. So let's use just two interfaces is sufficient. So it's a 1941 model. So connect the two switches to the two routers. So let this be like this. Um, and this interface, this will be like this. Okay. Now, there's a kind of thing to be noticed here. The VLANs are spread across both sides. So we could do this way. You see here, the gateway IP address is 10.1 for VLAN 1. So it doesn't matter how it is spread across the two switches. Here, across both the switches, it is spread VLAN 1. But for all those computers across all these switches, the gateway IP address for VLAN 1 is 10.1. So this router can have that 10.1 as the gateway IP address for only one of its sub-interfaces. Even across the physical interfaces, different physical interfaces, only one sub-interface can have 10.1. Similarly, only one of the sub-interfaces across all the physical interfaces put together can have 20.1 as the gateway IP address. So it's up to us to decide whether we want both the gateway IP addresses on the physical interface G0/0, or we want to give 10.1 to 0/0 and 20.1 to 0/1. It's up to you. So either way should be fine. So let's give kind of one sub interface to each physical interface. So let's first set up the database. Already VLAN 1 is there, so let's create VLAN 2. So this is VLAN 2 add. Now go to physical interface 0/0, turn it on right away. Go to the CLI. I'm going to create only one sub interface here corresponding to 10.1. So press enter. Already we are in that interface. Let's get the sub interface in G0/0. So this is 0/0 and dot I'm going to create for VLAN 1. So dot 1. Press enter. Then encapsulation dot 1Q1. Then IP address. The gateway IP address is 192.168.10.1 slash, this is subnet mask is 25.255.25.25.0. And then say no shutdown. That's fine. Come back to the main, this config window, click on 0/1, turn the port status to on, go to the CLI. So press enter. Now we are at 0/1. So in this interface, we can create that 20.1 sub interface. So int g0/1, very similar to this 0/1. Now dot 2. I can make that 2 to belong to this physical interface. So this is 1.2 sub interface. Press enter, enter encapsulation dot 1q2. That's the VLAN number. Press enter, then the gateway IP address 192.168.20.1, 255.255.255.0. Press enter and say no shutdown. So that should be fine to really have everything turned on and running. So let's now try to ping. Before that, let's make sure this connection is set up. So this is interface 6 are the two switches. This is also switch, right? So we need to make that a trunk connection. So interface 6 is right now access at the switch. So make it trunk. So the two VLANs are selected. All the VLANs should be selected. And then this interface 6 here for that switch should also be a trunk. So note down the interface number correctly. This is interface 6 of that switch. So both these connections should be in trunk mode as well. So anything between a switch, two switches, or switch and router should be in trunk mode. So let's place a cursor on this and see how the sub interfaces are set up. So 0.1 is set up under 0. 1.2 is set up under 1. So 10.1, the corresponding gateway IP address is for 0.1. 20.1 is for 1.2. So this should be still fine now. So let's try to ping command prompt. So let's try to ping to something here. Ping 192.168.20. We have 10, 11, 12, 13. So let's pick 12. So the first may be a request timeout, then you should be eventually be able to get it. You see, you're getting it. Okay, so let's try from some other device here. Let's try from here to here, or even within the same VLAN, 192.168.20.10. Be able to get it. Similarly, 10.10 this side, be able to get it as well. Okay, so this is how you implement example 3. So again, remember that the gateway IP address can be set across only one sub-interface, even if you go across the physical interfaces. You cannot have the same gateway IP address for more than one sub-interface. Okay, so in situations like this, where the VLANs are spread across the two switches, it's up to you to decide which, because ultimately the sub-interface gateway IP address is going to be involved in the forwarding of the packets. So that should be good enough. Okay. So let's save this as video example 3. And I click new, which asks you to save, say yes again as well. We'll stop with this.